from Indiana University. And then after that, I spent about 6 years at a tree care company in Chicago. So I started out as a climber, brush dragger, plant healthcare technician, and then eventually worked my way into a sales arborist position. And then after that, I got picked up by Rainbow for this job. And basically, for those of you who don't know Rainbow, or what this fake job title means, is Rainbow really brings, we're a tree care company in Minneapolis, but my branch of it, the Scivant, Scientific Advancements, focuses on providing technical support and hands-on training to bring you guys science-based products and protocols to the arboriculture and landscape world. So my job is a lot of education and a lot of meeting with companies and cities out in the field to train them up on all of these protocols that we're going to kind of review today. I am in Portland, Oregon. I just moved out here though, so I'm new to the West Coast, and my job is going to be supporting West Coast and Rocky Mountain territories. So Alex and I kind of convened on what pests to talk about, and I have tons of experience with a lot of these, but then a few are just like a little bit different from the Midwest to the West Coast. So feel free to reach out if you have specific questions. And my team is amazing. You may know Tony Smith, who's based out of Colorado. Anyway, she covers the Rocky Mountains, so she's also a wealth of knowledge if you guys ever need us. All right, so quick agenda. We're going to do a high-level overview of IPM. And then I just want to point out, these are kind of what I'm going to cover, but basically categorized into bigger categories: leaf diseases, sucking, chewing insects, boring insects, bacterial diseases, vascular wilts, and cultural issues. And those are kind of all of the issues that we face within our tree problems. So we're going to breeze through a lot of this, but you guys, I think this is a nice way to just kind of categorize in your brain. All right, so integrated pest management. For those of you who are not super well, in this world, IPM is, sustainable science-based decision-making processes that combine biological, cultural, and chemical tools to manage and reduce risk for pests, and pest management tools to minimize, your economic, your health, and environmental risks. So we really need to focus on diagnosing problems properly, reviewing our cultural and chemical options, and then determining our best application techniques given the pest, the pathogen, and the site. So we're not just going to say a specific thing for a specific problem. We really need to take actual things into consideration in order to be stewards to the environment. Quickly, but most importantly, I would say, I feel bad that I'm not spending more time on this because typically I would spend 20 minutes talking about this, but cultural management is really a huge part of what we deal with as arborists. And I think we kind of fail at this sometimes. A lot of the insects and diseases that I'm going to talk about can actually be pretty much prevented if we actually manage the cultural aspects of our trees. So that is proper watering, proper pruning, mulching, using an air spade or an air tool to reduce soil compaction and girdling roots, properly utilizing prescription fertilizers or other soil amendments to help the rhizosphere, the soil rhizosphere. And then I'm mentioning this quickly because it will come up, but paclobutrazol, that's a plant growth regulator. We're going to talk about it more tomorrow. Ours is Cambistat, but it's a really great tool. There's a lot of options to kind of improve the vigor and health of trees by utilizing that. Again, we'll talk about it more, but these are kind of our high level things that we should be thinking about first and foremost before we ever want to think about a chemical. All right, so, and actually just quickly, because I know that some of you guys are more like climbers or office folk, but plant healthcare is PHC is what we in the industry, right, use. And basically you're always taking your comprehensive program to manage your health, appearance, and vitality of all your trees and plants in the landscape. And then the one thing that's important to note here is that a lot of this you have to take into consideration your client expectations. So for those of you who are private arborists, some people are going to be like, please, it doesn't matter as long as my tree looks okay. Some people are going to be like, I don't want a single insect on this tree. And that's two totally different thresholds, two totally different management plans. And then you also, as most of you know, need to bear in mind the budget. So it'd be great if we could rid ourselves of every problem on the landscape and keep all of our trees alive. But unfortunately, sometimes removing and replacing a tree is actually going to be the more budget friendly thing to do. So just kind of weighing those things out. Okay, so tree care application techniques. I'll kind of talk about these. I'm just going to give these quickly, but basically systemic applications. We have our tree injections. Those are micro and macro injections. So micro being smaller amount of product going in, macro being larger amount of product going in, two different systems, a variation of systems out there. Soil application, those are soil drenches or soil injections. Basal bark sprays, and then our non-systemic, those are our contact sprays, would be like foliar and trunk and limb. And I'll show you just a couple of pictures for those of you who may not be directly involved in this. But our spray applications, on the left, you've got kind of your, what it would look like if you were spraying foliar or limb and trunk sprays. Depending on the pest, it varies. If it's like a leaf chewer, obviously you'd spray the leaves. If it's impacting the trunk, you'd spray the trunk. But that's a direct contact. And then basal bark spray, this would be more for systemic, but that's where you just kind of use a wand and spray the bottom part of the tree. And then soil applications you can either do on the left where you just kind of like make a little trench and then pour it around, or this is just our product that we have. You can put it through any sort of soil injector and put your product in that way. So just keeping it high level. And then we've got our macro versus micro injection. Micro injection having a little bit smaller tubing, smaller amount of volume going in, like maybe up to 1 liter, versus your macro injection where you're putting like gallons and gallons. So that would be like, I'll talk about it quickly, but Dutch elm disease macro injection is really great versus so fungicides more with macro injection and then insecticides more with micro injection. And then just quickly, the difference between this is when you're dealing with a systemic insecticide, it doesn't need to, coat everything because it translocates throughout the tree, versus like a fungicide, you basically need to line the entirety of the vascular tissue in order to get control of, whatever pathogen you're dealing with. So that's your differentiator. So you really got to look at the biology and the science behind the pest or pathogen that you're dealing with. Okay. All right, let's get into it. So we'll start with leaf diseases. Most of these are pretty aesthetic, but will, wear down the trees over time. So I'll kind of go over some symptoms and signs and then give you just our basic protocol for treatment at the end. So apple scab, that's kind of a huge one in the landscape. I know in some areas of the Rocky Mountains, you guys don't get a ton because it's dry enough that this doesn't impact you, but anywhere where you get humidity, this pretty much is there. Apples, crab apples, mountain ash, pears. You've seen it before. It's these little brown sort of velvety spots that come on the leaves. And then eventually it kind of grows together and then the leaves turn brown and they fall off. So you'll see pretty early leaf defoliation. And it can also impact the fruit. So people who have apples get upset about this more in the orchard kind of landscape, or people who have apples at their homes. Again, mostly aesthetic, but year after year, especially in those kind of cool, wet springs, that will cause the tree to defoliate super early, and then over time, decrease the vitality and livelihood of the tree. Powdery mildew, this is a huge one in the landscape. You guys have seen it on your dogwoods, your roses, everything. It's just like the picture shows. It looks like there's like white powder on the leaves. And then eventually that can turn into also they're like pin-sized spherical fruiting structures. So little pin-like structures. And they can be like one at a time or a big cluster. And those are the overwintering bodies of the fungus. And then, okay, there's a ton of different needle casts. I've been hearing more and more reports coming out of the Rocky Mountains that needle casts are there. I feel like for a while they weren't. So Rhizosphaera is one, but we've also got Diplodia, Dothostroma, spherosis. Like there's a lot of different things, and essentially they're kind of the same, but there's a few differentiators, but they're kind of the same, and they're also have the same treatment protocol, which is my point. So in the case of Rhizosphaera, these impact most of our conifers. Symptoms typically begin on the bottom because the spores are on the ground, and then when it rains, it splashes up. So you'll see dieback on the bottom part. The 2-year-old needle, so not the new growth, but the second growth, will turn kind of brownish, purplish. You'll see the fruiting bodies, which I think, so there's that kind of browning that you'll see. And the fruiting bodies, if you look close, this is really zoomed in, but you can actually see them with the naked eye, little black dots. Symptoms don't become visible until like the later in the season though. So in a first year of Rhizosphaera, it'll look fine all spring, all summer, and then kind of pop up at the end of the summer or in the fall. But then year after year, this will just continue to get worse because those spores, just keep overwintering the soil, bouncing back up with the rain, and then bouncing back, through the branches. So has become more of a problem as our climates have been changing. And basically, it doesn't really matter what kind of leaf or needle cast you have. There's only a couple of treatments out there. So cultural practices first and foremost, because as we know, a healthier tree is less susceptible to getting diseases. So doing all your proper watering, mulching, etc. And the one thing I want to mention about watering is that you don't want to be watering the leaves or the needles, right? Because all of these spores and funguses just are the happiest when they're wet. So if you can keep your trees dry, you're going to have the best success combating this. And then sort of the industry standard treatment protocol is 2 to 3 foliar fungicides with rotating modes of action, which I'll talk about in a second. Spray applications begin at bud break, and they're timed at about 14 to 21 day intervals, depending on the label of the chemical. So I'm going to talk about this really quick. This is blurry and you don't need to know any of this, but fungicide rotation is kind of the industry standard. And this is to prevent resistance. So we've never seen resistance of fungicides in arboriculture, but we've seen it a lot in agriculture. So it's we've adopted this as a best practice just to prevent this from happening. And okay, you don't need to know the modes of action, but basically there's different classes, different modes of action. Some block cell division, some will inhibit sterols, things like that. And for example, class 3, so propiconazole, myclobutanol, those are 2 really common ones. Those are class 3 fungicides, and they're both protective and curative. And then M5, so that's your chlorothalonol, those are contact and systemic. And then there are some that are literally just a contact and some that are just a systemic. So this is why I mentioned this. It's not super important. If you guys have specific questions on it, let me know. But it is basically just, again, to prevent any resistance and also just utilizing those different modes of action to get better efficacy. Cool. So sucking and chewing insects. All right, so Alex wanted me to hit this one. I guess you guys see this a lot. Cooley spruce adelgid, hitting your Colorado spruce and Doug firs, which obviously are pretty important in the landscape. On spruce trees, they look at the bottom picture here. They form these kind of pineapple-shaped galls, and they present on the new growth, and then they turn brown. So this is kind of alarming to homeowners or, even people who are out on a walk. They're like, ew, what are these, right? Galls are not formed on Doug firs, but the needles can become discolored and turn yellow and drop. So again, people are like, why are my Doug firs losing their needles? That's alarming. But then if you look close, the picture on the top, the appearance is pretty similar to aphids, just kind of that white fluffy thing, right? All adelgids are kind of white and fluffy, but that's what that looks like. I think that's a nice close-up picture. This is pretty easily managed So again, your cultural management is going to be great because adelgids aren't actually super harmful to trees. They're, you know, in small populations. So if you can just keep your trees healthy and keep the populations down, you'll be fine. But again, depending on your sort of client expectations, these are super easily managed by just a soil application of either imidacloprid or dinotefuran. So pretty easy annual application. Elm leaf beetle. We've been seeing a ton of this in the Rocky Mountain territories and have actually been doing quite a lot of studies because it's become so alarming. You can see in the photo, as soon as those elm leaf beetles start to feed, it becomes really obvious and they look really bad. It's pretty unique though. This is a unique pest. When you see it like this, it's nothing else. But I think the tough thing is that there's a lot of other pathogens that impact elms. So we're like kind of on high alert because it seems like a lot of things are killing elms. And this is already like our second go at elms, right? Because we lost so many to Dutch elm disease in the 60s, 70s. Anyway, so with this guy, annual application of systemics works great. So imidacloprid, dinotefuran, also trunk injection. So if a spray or a soil application isn't possible, trunk injection works great. Most elms are too big for this, but if you needed to do a contact spray, that would be at crawler emergence, and that's kind of earlier in the season, growing degree days, 363 to 900-ish. And if you have questions on growing degree days, I can get you a little calendar for that. The one thing to note with this, with clients, is the expectation is that there will be visible damage, since basically the chemical that you put into the tree, the bug will need to feed on it before it will die, right? So in order to ingest the insecticide, it has to start chewing, so you will see some damage. It's unrealistic to tell a client that it will look perfect, right? You need to let it feed and then die. So soft scales. We've got scales, and I'm gonna try to keep this as least confusing as possible. So we've got soft scales and armored scales. I'm going to talk about soft first. They're up to 1/4 inch or larger. They are bigger scales generally, smooth or cottony, and typically round. And the thing to note about soft scales is they are phloem feeders, which means they excrete a ton of honeydew and they cause sooty mold. So if you have a scale and you're like not sure what it is, soft scale honeydew, armored scale no honeydew. They produce hundreds to thousands of eggs. Most have 1 generation per year, and they overwinter as nymphs. There's kind of the life cycle on the right. This is from Dr. Boggs, but I think this is important because this is kind of the distinguisher. So these guys, these scales, they feed on the phloem, which is what creates all of that honeydew. Oops. All right, so they insert their stylet into the phloem. They damage the cells, producing the leaf symptoms. And then the main damage is the large quantity of honeydew. That's a nice close-up picture, but they literally drip. And if you have a bad enough infestation, if you sit under it, it's like it's raining. And then you see that black sooty mold, it gets all sticky and then attracts a ton of other things like flies, bees, wasps. It's really awesome if it's right over your patio. So one that I'm only going to talk about a couple species. There's a ton of different scales out there, like dozens of scales. Lecanium scale is a big one that hits a lot of trees all over the country, but especially out here. You'll see them on your oaks and dogwoods typically. And the feeding damage can deteriorate the health of the tree. You can see pretty bad branch dieback. Again, tons of honeydew, tons of sooty mold. And then this is the reason I mention the growing degree days at the bottom of these, is because when you're treating for scales, you really need to be focused on treating the crawler stages, because the moms, that's what you see in the picture. Those are really hard to manage because they suck in the chemical, but they can be like lots of layers. So the stylets aren't necessarily getting to where they need to get in order to get that. Anyway, so, and the crawlers are also the most vulnerable because they're the smallest, right? So kill the most vulnerable stage, not back the population. So the crawler stage on these guys are 700 to 1600. which we'll talk about the management in a moment. So that'll make more sense, hopefully. Our armored scales is our hard scales. Those are smaller, typically less than 1/8 of an inch long. So sometimes you need to look kind of hard for these. They've got a waxy sort of shell coating. They do not produce honeydew, and they are not mobile in most of their life stages. So that's important, again, with management. They are definitely less productive, less than 100 eggs per insect, but they do produce several generations per year. And sometimes do have extended crawler emergence. So again, management, maybe need to do a few different applications. And then they also overwinter as nymphs and adults. All right, so this is, again, the other slide from Dr. Boggs. They insert their piercing and sucking mouthparts into the plant cells, so not the phloem. So that's why it's important when we're talking about treatment. They damage cells producing the leaf symptoms. That's a great example of what it will look like. And then imidacloprid is not effective against armored scales, and that is because they don't feed in the phloem. So a couple of armored scales, pine needle scales, big one, you'll see it all over. They impact pine, spruce, Doug fir, cedars. You'll see a lot of needle chlorosis, so yellowing of the needles, premature needle drop. You can see those white flecks typically on the needles, and then just overall reduction in plant vitality. They have a couple of overlapping generations, one really early in the season and then one much later in the season. So you can manage these at a couple of different times. Oyster shell scale, another one that we see a ton of, and this one is hard to identify sometimes because they're so small. If you look at the bottom picture, it just kind of looks what the twig or the bark would be, but they're not. And you can actually like peel those off, those little scales off. Anyway, they impact a ton of different species, but here we've got listed ash, dogwood, maple, elm. Feeding damage, again, limb dieback, tree mortality really weakens the plant. You also see these on a lot of like, what do you call it? Like ornamental plants and ground cover and things like that. These guys only have one generation per year, an early stage crawler, so 363 to 707. So again, like an early application will give you, reasonable control of that crawler stage. Okay, so here's kind of the overall control strategy. So moderate to severe scale infestations are actually kind of difficult to manage just because of the life cycle of the scales. So this is kind of what I recommend. If you've got like severe infestations, you'd be kind of looking at a dormant spray of horticultural oil and IGR, that's insect growth regulator. There's a couple of different ones out there. The one that we use is pyroproxylene. I forget how you say that. Anyway, so those work great to kind of manage that dormant stage. Then, okay, so I'll start with soft scale. Then soil or bark spray of imidacloprid or dinotafurin will work on, remember, only your soft scales, not your armored scales. And that imidacloprid needs to happen in early spring because it has a slower uptake. Dinotafurin has a quicker uptake. So again, like, let me know if you guys have questions. I'm trying to keep this like pretty high level, but both of those will work, soil application or bark spray. And then that crawler contact spray is really what is probably arguably the most important. That can be dinotafurin, any of your sort of like permethrins or bifenthrins, or an insect growth regulator. And this is where that whole like IPM thing comes into play because, right, dino is a neonicotinoid. So if you have any flowering issues, you don't want to spray that. And then permethrin and bifenthrin, those are kind of your contact cover sprays. And the thing is like, no, they're not neonics, but they kill everything. Dinotafurin, even though it is a neonic, has a shorter residual. So, right, so all things are not created equal when it comes to like environmental issues. Like all of these have a time and a place, in my opinion. And then insect growth regulators, those are definitely your best as far as environmental. But if you've got a really bad infestation, this may not be enough on its own, right? So these are kind of the ebbs and flows of plant health care. And then on the right, armored scale, similar. The only thing to note, as I already said, imidacloprid does not work on that type of scale. So hopefully that explains that without being too confusing. All right, on to our boring insects. Let me check time. Okay, perfect. White pine weevil. You guys have seen this, I'm sure, on your white pines, jack pines, spruce, and a few others. You will see little sort of like glistening droplets of resin coming from that feeding puncture right below those terminal buds. You will see girdled stems, wilted shoots, and those reddish brown needles. That picture on the top right corner is quintessential white pine weevil. Repeat infestations year after year will result in a deformed and forked tree. These are relatively easily managed. You could do a fall application of imidacloprid that basically will get taken up into the tree, starting to reach its peak of chemical right as those emerge in the early season. Otherwise, your application, your contact sprays, those can work. And the phenological indicator is 1 week after forsythia reaches full bloom. And basically you do 2 applications kind of like 2 to 3 weeks apart. All right, I'm keeping these 1 slide each, round-headed borers on this page and then flat-headed borers on the next. So there's a lot of these out there: ambrosia beetles, western pine beetles, mountain pine beetles, a ton of other different ones. They can pretty much impact every tree species. I think one list that I saw was like 200 tree species. So it's a lot. Assume that you can get them on everything. Feeding damage, sign and symptoms look like yellowing of foliage, branch dieback, and then you can actually see pitch tubes from excavation with most of these species of borers. So if you look closely, you'll see like a frass tube, like a, who was it? Someone, Dr. Coyle out of the Southeast calls them poop tubes. So I should have put a picture of that on here, but look it up. Pitch tubes you can see. And then treatment is really managing the cultural side of these things, because mostly round-headed borers will go after only stressed trees. The only exceptions there are some of our sort of invasive pests. We deal with a few of those in California. I don't know how many of the invasive brown-headed borers you guys have in Montana though. So you can manage these if basically you can slow them down. Every other year, trunk injection, micro-injection of emamectin benzoate, and then contact trunk and limb applications work. But systemic insecticides, so like our dinos or imidacloprids, don't work because the beetles don't actually feed on the phloem of the tree or the tissue of the tree. They just like bore in and out, right? Okay. Flat-headed borers, again, we've got a ton of these: apple tree, cedar, western sculpture pine beetle or pine borer, emerald ash borer is also in the flat-headed borers, which we're going to hear more about that tomorrow, and I'm going to talk about it a little bit more tomorrow because that is what I have done all of my work in. Anyway, flat-headed borers can impact most tree species. Again, signs and symptoms, you'll see the galleries in the trees because their larvae actually feed in the xylem of the tree. And then branch and tip dieback, and then death in some cases. And again, similar to round-headed borers, most of them will be going after stressed trees. So managing the cultural side of things is important. Again, exceptions are invasives, especially like emerald ash borer is a huge one, right? Those ones go after any healthy ash tree. So you can treat for them, but it's a different sort of treatment protocol. But it's every other year of trunk injection of emamectin benzoate, works amazing, works great. Soil applications of systemics like imidacloprid or dinotefuran work awesome as well, depending on the infestation. But if you've got low infestation, those work great. And then also contact trunk and limb applications can work. And if you guys want to dive into any of the specific ones, let me know and I can get you more information. I just kind of wanted to keep these brief. We don't need to talk about flat-headed borers for the whole thing, or we could, but that wasn't what I was asked to do. Okay, so bacterial disease. I'll just bring this up really quickly. Fire blight. I know we deal with this a lot, kind of everywhere now, it seems. But there's our Xylella. Crabapple, apple, pear, mountain ash are our big hosts. You've got two different sort of stages. We've got blossom blight and shoot blight. The blossom blight, basically the flowers will look like they've been soaked in water and they wilt and got super sad, and then they turn brown and they look like they're dead. And then shoot blight is when the leaves will wilt, turn brown, and then remain on the tree. And it looks like it's been fire scorched, like they look black. So that's why we call it fire blight. And the branch tips on the infected twigs sometimes kind of like lean over to create this sort of shepherd's crook. It can also cause these sort of like cankers that cause this like callus ridge down the branches. So treatment, and I should have put this in there, but cultural treatments, of course, and then pruning. So pruning out, you have to prune past the infection that you can see though. So if you see the infection on like the top 6 inches of the branch, you need to prune back like a foot past that, which can leave you in a really interesting situation as far as making a tree look very silly or almost like it's been topped, but that's the option. And then that in conjunction with a couple of different things. So copper is sort of the industry standard for this. 2 to 3 applications at bud break at 14 to 21 day intervals. I don't love using copper, but it does work for this. And then it's kind of a twofer because copper sprays also help manage scab and rust, which we talked about earlier, which also impact crab apples, pears, and apples. So there's kind of one option. The other thing that works really well is a trunk injection of oxytetracycline. So that is a micro injection into the base of the tree. The problem with this is that it does need to be done on an annual basis. And typically speaking, like general rule of thumb, we really only like to be injecting every other year so we can allow trees to compartmentalize. So in this circumstance, maybe you could do a trunk injection a couple years, get it, knocked back and manage, and then manage using the rest of these options, other cultural options, get it looking good, and then so you can allow those injection wounds to heal. Because anytime you inject a tree, anytime you drill into a tree, you do damage it and force it to undergo some stress in order to compartmentalize and heal up. That being said, of course, there are circumstances where the benefits far outweigh that small amount of damage. So the other thing I will mention, which is proven like really, really great to manage fire blight, is paclobutrazol. So I was talking about Cambistat earlier. This is a plant growth regulator we will talk about tomorrow, but has been hugely beneficial in managing fire blight. That is a soil application and it's done every 3 years. So that is one thing that you can do that can suppress for 3 years, which is, a lot of bang for your buck, in my opinion. Okay, so vascular wilts. We've got a few of these, and some of them you can do stuff for and some of you can't. So I'm going to talk about Dutch elm disease really quickly, but of course you guys are often concerned about verticillium wilt. In the Midwest, they're really concerned about oak wilt. Like verticillium wilt, there's not a lot that you can do, but a few of them, like our oak wilt and Dutch elm disease, we can actually manage preventatively. So Dutch elm disease is only relevant to some of you guys, but it's also really interesting just to learn about. And in the Pacific Northwest, we actually deal with this quite a bit. Oregon, Washington, and even Northern California has quite a bit of Dutch elm disease. So Dutch elm disease kind of swept through the country in the 60s and 70s. Are actually like pretty low amount of American elms left, but the ones that we do have, it's cool that we can preserve them. Signs and symptoms: leaf yellowing, curling, drooping, and defoliation. So that kind of top picture, we call it flagging. The tree will look fine, and then there'll be one branch that just all of a sudden they yellow and they're drooping. Symptoms begin about a month after infection. So Dutch elm disease is vectored by elm bark beetles, nidodulid beetles, into the 2 to 4 inch kind of branches, so like the small branches at the tips of the tree. And then it can also be vectored via root graft to any other American elms that share root systems. So once one gets it and then it grows down, it can then go into the next one, if that makes sense. So when I talk about the management, it's like aggressive. But Dutch elm disease is an aggressive pathogen, fungal pathogen that will kill a tree regardless of the health. So health. You need to keep that in mind. Like, yes, cultural practices are great, but this doesn't care. It grows in the current year xylem and then basically grows down it. And then the tree's response is to produce tyloses, which plugs up the vascular tissue. So that's why you see the dieback. All right, so this is I'm just quick and dirty, but our management protocol: you scout the trees, you inspect for Dutch elm disease. Okay, and this is assuming that you've treated. So the treatment at the end, that's our thiabendazole. That is a macro injection that you would treat with an infusion, so Arbortect. That lasts for 2 3/4 years. So then by the 3rd year, you need to be doing the scouting, which is why we're saying scouting in 3rd year. But you'd scout the trees, inspect for Dutch elm disease. You remove any infected ones, any like lumber yards that have infected wood away from the other trees. So sanitization is actually a really important part of this. When you're looking at ones that are going to be transmitted through root grafts, you would disrupt that by severing the roots. There's a ability for you to trace out an infected part in a tree and then actually cut out that infected portion. But a lot of times by the time the tree has actually gotten it and you can see it, you'd have to remove it. And then protection. So preventative protection using Arbortect is amazing. It works 99.9% efficacy. We treat, Rainbow has a ton of elms in Minneapolis. I think they treat like 70,000 elms, and I think they've only lost on average like 1 per year. And a lot of times it's just like old age coming into play as well. So anyway, we can talk about this more. I wanted to keep this pretty high level. This is not nearly detailed. My company, this is a plug for more CEUs, but Rainbow will do a huge Dutch elm disease sort of webinar symposium. We do it every spring, but it's basically like a 3 or 4 part thing where you guys can get to use and learn about this if this is something that you are dealing with and actually want to know more about. Anyway, cultural issues, chlorosis, huge issue that we see out there. Basically just the yellowing of leaves, the lack of chlorophyll in leaves of trees. And it can impact many species. Ones that we see a lot of it in are maples, birches, pin oaks, but it can also be a lot of other things. You'll see the yellowing in between veins on the newer foliage, necrotic areas developing on those chlorotic leaves, and then tip dieback and decline, even tree death in severe cases. And if you've seen a chlorotic tree, like say in your neighbor's yard, and you've just seen it year after year after year, and they have not done anything, a few years and it just will look terrible and die. So there are things we can do to intervene. But basically chlorosis is when the ability for a tree to manufacture chlorophyll has been compromised. And this can be due to a couple of different things. One can be micronutrients such as iron or manganese not being available in the soil. It could also be that it's in the soil, but the soil is like a clay type soil that is binding up those free agents that can't allow those micronutrients up into the tree. And then it can also be because of poorly developed roots. And then the thing about, so if you've got like a really crappy rhizosphere that can't absorb, right, micronutrients, that's going to create chlorosis. But the thing about chlorosis is kind of like a duality. We call it like the catch-22, because you need to have like healthy green leaves that can actually, you know, create food and absorb sunlight in order to create a healthy root system. But then if in turn, if you don't have a healthy root system, you don't have healthy leaves. So lots of different like management thinking, you know, high level thinking. Anyway, I apologize. I started getting tired of putting these slides together and realized there's a lot of words on this, but basically there's a few different treatment strategies. Verdure is our tool, but it's a micronutrient injection. We do it with macro injection of either iron or manganese. It works amazing. It's 2 to 3 year application. And basically you inject the tree, you take it, it takes up the iron or manganese, and that'll cause, you know, pretty much within the season, green up, allow the tree to increase chlorophyll in itself. And hopefully you're like mending that duality that we just talked about. But it can be kind of a band-aid, because if you're not actually, you know, improving the rhizosphere, or if there's some other root issue that you're not addressing, you could just be putting that in to make it look nice, but not actually solving the problems long-term, if that makes sense. Again, paclobutrazol is amazing. We're going to talk about this tomorrow, but it increases chlorophyll production and improves fine roots, so improves root systems. So that can actually address both of the kind of causal agents of chlorosis. And then I just wrote, you must address the underlying factors that cause chlorosis in the overall management strategy. So if it's like a soil compaction issue, you need to decompact. If it's a pH issue, you can adjust the pH, and then other practices to stimulate root development and water absorption, things like that. All of the cultural practices to promote tree health and to create a more suitable growing environment. So this is like a multifaceted approach. And again, there's probably some clients who are going to be like, no, it's fine, just remove the tree. But there are certainly things that can be done. And then once you do some of these things, you're putting the tree on track to be successful for its whole life. So you don't need to like mess with it a million times once you've gotten it on the right path. Alex wanted me to mention drought stress and construction damage. Oh, and I apologize. These pictures are a little bit blurry, but we know what both of these are, right? Drought stress, you guys see it all the time. Improper watering, or just lack of watering, or it's droughty and it is what it is and water is expensive. And then construction damage, which we love to see the picture on the right where just absolutely no care has been taken. Treatment strategies for both of these are pretty similar. Paclo application, this is pretty industry standard. Thickens the leaf cuticle and trichome hairs, so that helps with drought stress, and then it also improves the regeneration of fine root growth, so that is great for construction damage. Preventative measures such as root pruning, so if you know that you're going to have to cut and lay concrete in a certain spot, if you can root prune and make nice cuts on those roots instead of like getting them all scraggly and crazy and compacting all of the soil with all of your trucks, you're going to be much better off. Putting in those tree protections of those critical root zones is going to be hugely, that's the best thing that you can do out of all of these things. Putting up your fencing, putting up your signs, and I will mention quickly, I always write these into contracts because I've had so many contractors like come in and just ruin things, and if you write it in that there's a fine or something of the sort, then they're more likely to recognize that you're serious and not touch your root protection zones. Nothing says rip me down like orange fencing for some reason. Anyway, decompaction with air tools and other practices that can stimulate root development, and then additional cultural practices, soil products to promote tree health and create more suitable growing environment.